Hi, I'm Somikta and I will be solving question number 1 of homework 5. So, what do we have in question number 1? So, we have been given x, y, z, which are the random variables, and the density function of x as ux minus 1 minus ux minus 2, and the density function of y as uy minus uy minus 1, which essentially means the density function of x varies between from x equals to 1 to 2 and y varies between y equals to 0 to 1, and the random variable z is defined as x plus y, and it has also been given x and y are independent. So what do we need to find? So we need to find the density function of z by convolution method and geometry. So first we will find the density function of z by convolution method. So we know that the distribution fz can be written as probability of z less than z, probability x plus y is less than equals to z. So this is the generalized equation in terms of the density function of xy to find the distribution fz. The density function fz is equals to the derivative of the distribution function. So assuming fz, the distribution function is the density function fx comma z dz from az to bz. So the density function f of z can be defined as dbz by dz f at bx equals to bz comma z minus daz by dz f x equals to az comma z plus integral az to bz del fx comma z del z integral from az to bz. Equation number 2. It comes from the Leibniz rule of chain rule. So now, using equation 2, we can write the density function as follows. So del z minus infinity to z minus y z minus y, because x plus y equals to z. So now bz is z minus y, az is minus infinity. So what do we have here? We have dbz by dz. So derivative of z minus y with respect to z is 1, fxy z minus y comma y minus 0 plus minus infinity to z minus y del z dx dy. But fxy x comma y is wholly dependent on only x and y and not on z, so its partial derivative will be 0. Okay. Now the density function can be written as minus infinity to infinity fxy z minus y comma y dy. Equation number 3. Now since x and y are independent, density function can be written as minus infinity to infinity fx z minus y fy of y dy, or minus infinity to infinity density function of x and density function of y at y equals to z minus x, and the integral term is dx. So we just replace the values and we will go with the second formula. We will go with this. So fz comma z, fz is, we just replace the density function of x and y, so it becomes a series of step functions multiplication. So this function corresponds to x varies from 1 to 2 because the integral term is dx. So the limit changes from 1 to 2, u z minus x minus u z minus x minus 1 dx. We'll just replace z minus x with t. So the limit changes from z minus 2 to z minus 1, and it becomes ut minus 1 dt. Okay. Now just separate out the integrals, and then we have what? ut varies from z minus 2 to z minus 1, and ut minus 1 varies from z minus 2 to z minus 3. Further simplifying, ut varies from z minus 2 to z minus 1, and another ut varies from z minus 3 to z minus 2. So now there will be some cases. First case is z greater than 3. Z greater than 3, everything is positive. Okay, so this is 1, this is 1, this minus 1, this becomes 1 minus 1 is 0. So for z greater than 3, the density function of z is 0. When z is less than 1, similar case, everything is negative, so 0 minus 0 is 0. Now the third case is when z is between 1 and 2. 1 and 2, the z minus 2 is negative, z minus 3 is negative, so this becomes automatically 0. Since it's negative, ut is there for t greater than 0, so the limit will change from z minus 2 to 0, z minus 1, and this is z minus 1. And case 4 will be when z is between 2 and 3. 2 and 3, so this is automatically positive, positive, but this is negative, but this is positive, so limit changes similarly, and this becomes 3 minus z. 3 minus z. So f, the density function becomes what? 0, z is less than 1, z minus 1 for this, and 3 minus z for z between 2 to 3, and 0 for z greater than 3. Now we need to find using geometric method. So this is what x and y varies. Y varies from 0 to 1, x varies from 1 to 2. Okay. So for z, z is what? X plus y. So for z between 1 to 2, 1 to 2, which means x 1 to 2, z is less than, but because this line, the diagonal line, is x plus y equals to 2, so it will lie in this portion, so it is anyways going to be like the anyways going to the shaded portion. So fz is what? Fz is the area of the triangle, which is half z minus 1, this is z minus 1, and the density function, take the derivative, which becomes z minus 1. Now when z is greater than 2, greater than 3, so it will be above the diagonal line, so z will obviously lie outside of this, outside of the limit of x and y. So this is the area of this quadrilateral, which can be defined as z minus 1 whole square minus 2 of z minus 2 whole square by 2. Expanding it, it becomes minus z square plus 6z minus 7 divided by 2. Take the derivative, this becomes minus z plus 3. So it gives the same result as we obtained from the convolution result. Thank you.